Hello and welcome to Geometry. I'm Mr. McWhorter and we're going to talk about nets and drawings for visualizing geometry. Being able to visualize geometry is a pretty important thing. So when you shine a flashlight on an object, you can see a shadow. And in this diagram, what shape of a shadow would you expect to see on this wall over here? Yes, Raphael. Yeah, I think you're right. I think it would look like a rectangle. I think we would have the shadow that it casts is going to look like the shape that it's shining on. Thank you. What about on this wall? Who thinks they know what would show up on this? Oh, Katie. Yeah, it would be a right triangle. You would see a right triangle, kind of like that, because it's shining right on this right triangle here. So that's pretty cool. We're learning how to visualize geometry already. You can represent a three-dimensional object with two-dimensional figures or using special drawings. These two-dimensional figures here, the rectangle and the triangle, represent two different views of this three-dimensional object. A net is a two-dimensional diagram that you can fold to form a 3D figure. The net shows all the surfaces kind of folded out into one view. So identifying a solid given a certain net. The net at the right folds into the cube shown here. Which letters will be on the top and front of the cube? So what letter is going to be here and what letter is going to be here? Well, you might be able to tell by looking right here. This edge here is facing like the flat part of the D, which is right here. Kind of tells me there might be maybe a C right here. And then who's right above the C? Maybe like an E over here. If it's not easy to visualize, maybe take a look at these. You can see that these two are going to fold together. These two are going to fold together. And as you start to fold it together, you can see that C would be on the front and E would be on the top. Go ahead and pause the video, see if you can figure out what's going on here with number 1. Alright, well if this is B, that means that the front is here. So wrap around just one to the right of B is going to be C. There's going to be a little C over there. And then right on top of B, this line is going to match up with this line. So your E is going to be kind of turned over this way. Like that. Drawing a net from a solid. What is a net for this graham cracker box? Alright, so take our graham cracker box. We're going to open up the top and open up the bottom. Then we're going to cut this little side right here and start to flip that open. And here's our net. The width of the front panel was 14. That's right here. The depth, or the side panel, was 6 centimeters. Also 6 centimeters for the lid. And the height of the box was 20 centimeters. Alrighty, see if you can figure this one out. Go ahead and pause it now and then hit play when you think you got it. Okay, so what if I was to kind of keep the bottom where it is, but let each one of these sides fold down? What I would get is I would get a triangle folding down this way. I would get a triangle folding up that way. And I would get a rectangle folding out that way. And another rectangle folding out that way. This would be 4 centimeters there. The long side of each rectangle is 10 centimeters. And the long side of each triangle is also 10 centimeters. And then, actually this is the 4 centimeters, and then this is 7 centimeters there. 7 across this way and 4 across with the rectangle. So is there another possible net? Yeah, if I just unfold it differently, I could unfold, take this panel here and fold it up, take this rectangular panel here and fold it down. So that would give me 2 of these 10 by 4 rectangles right next to each other. And then 1 7 by 4 rectangle. And then if I had these triangle pieces flip out this way, it would be like short side there, long side there. That's 10, that's 7. Short side there, long side there. That's 7, that's 10. So there's different nets that you can make. So while a net showed us a two-dimensional representation where you basically kind of unfold a three-dimensional object, an isometric drawing that you can draw on this isometric dot paper represents a three-dimensional object with slanted lines giving you the depth. Also, at this point, I should mention that the secret phrase that you will want to write down in the margin of your notes is hungry juggler. Hungry juggler. So how would we make an isometric drawing of this cube structure here? Well, you start off by drawing the front edges, as you see here. Then we'll draw the right edges. And then we'll finish off with the back edges. Why don't you try to make an isometric drawing of this guy and hit play again when you're ready to check, see how you did. So I'm going to start with the front edge. I'll put my front edge right about here. So that's this one. Now I got 3 coming back from these corners. So I got 1, 2, 3 lines coming back from there. And now I'm going to connect them here. And now I've got a couple more front facing edges. I got 1 square coming up, 1 square coming out. So I'm going to go up that away and then over that away. Now I'm going to make these lines coming back. And then these back edges can get filled in. And this is clearly some of the best art that you've ever seen. You're welcome. An orthographic drawing is another way to represent a 3D figure. An orthographic shows 3 separate views: top, front, and right side. And it takes more time to analyze, but it does give you some unique information that you can't get from other views. So we're going to make an orthographic drawing of this picture right here. Well, we're not going to make it. I mean, it's there. But we'll explain it. So generally, you would start with the front view. So the front view has this tall rectangle and then this one coming out to the side. And solid lines are going to be visible edges. So visible edges that you can see from the front are going to be this rectangle here and then this little square here. So that's why we got this big rectangle here and then this little square over here. So what's this dashed line here about? Well, hidden lines, hidden edges, we write as dashed lines. So if this was like sort of see-through, you'd be able to see a dotted line coming across here. Wouldn't ya? You would. So we kind of show that right here. Then the right side view is looking from this direction. We would see again a tall rectangle here, a short little square here, and then another little square here. And that's what you see from the right side. From the top, if we go back to the front face and then just kind of flip it down towards us, we would see this square right here, and then this kind of little L shape right here. Alright, so let's try to make an orthographic drawing of this. Alright, so from the front, I would see this little square right here, and then there would be a little bit like twice as tall here, over one. That's this part here. Now I gotta go over 2 and down 2. So over 1, 2, and then down 1, 2. That's my front view. My right side view, I'll be looking from this direction. So I'm going to see, on the far right, I'm going to see a 1 across 2 high rectangle. And I'm also going to see a 1 by 1 square above it. And I'm also going to see this 1 by 1 square hanging off the side. If I was to look at the top view, I would see this little square hanging down. I would see another square right above it. And then I would see 2 long by 1 high right there. Once again, the most straight lines you've ever seen and some of the most intense artistic quality. We got a little Van Gogh going on here. That's really the end of the lesson. I want you to download the practice, work on that, use the answer set to check your understanding, then work on that formal write-up and submit it to me so that I can give you some feedback. Adios, mis amigos.